Alright, chapter 7.4 gets into division properties. There are two of them. But before we get to them, I just want to make sure we kind of look at this review, because this is the last section that has to do with properties of exponents. And I want to make sure we've had all this under control before we move forward. Remember that we've talked about zero exponents. What zero exponents pretty much said, number one, is that anything to the zero power is 1. For example, if you take 8 to the 0 or 1,000 to the 0, all those answers are 1. But in terms of your powers, at any time you have a zero property, that it actually just cancels out, leaving you with whatever there is left over. We've also learned that negative exponents want to move to the opposite side. So whenever you have u to the third, v to the negative second, that this v is what I call unhappy because it's got a negative exponent, and that it actually ends up with the u to the third staying here and v to the second moving down. We also have the multiplication property, which is when you have two powers of the same base. This means I have 6 u's and 7 u's, which means you do u to the 6 plus 7, or u to the 13th. And then the last one was the power property, which is that I have a power going to another power. So I have an exponent separated by parentheses, which in my brain, parentheses means multiply. But what that was is that I have 4 u's happening 5 times, which is where you do u to the 4 times 5, again in parentheses, which is u to the 20th. Again, those are the main 4 things that we've learned so far. Hopefully you've used that time to kind of get better at them. Today we're going to look at the final power properties, final power property, which is base and division. Again, this is on your notes, and it helps again to look at the foundation of what's going on so you can see it. If you ever have a fraction with a variable or any base that is the same on the numerator and denominator, you can imagine expanding those out. So here I would have 7x's on top and 3x's on the bottom. And what we know about fractions is that whenever you have something over itself, that it cancels out. So what happens is that x cancels with that one, this x cancels with this one, that x cancels with this one, and all I'm left over with are 4x's on the top with nothing on the bottom. So just 1 on the bottom, which is just the answer of x to the 4th. Again, everything on the bottom canceled out, which is why I just put a 1 there, because remember there is an invisible 1 in front of that, but of course we don't put that in the answer. If that was also another one where we had x to the 2nd over x to the 6th, this means I have 2 x's on top, it means I have 6 x's on the bottom. Again, with the cancellation rule, those sets of x's cancel, and what we have now is 1 on top because everything canceled out, with 4 x's on the bottom. And of course that is 1 over x to the 4th. But let's look at this carefully and think about, some of what just happened here. Do we really need to do all that work? To me, you do not, because if you actually did 7 minus 3, you get the answer of 4. Again, top minus bottom, 7 minus 3, you get the answer of 4. But on the other one, if you did top minus bottom, 2 minus 6 is actually negative 4. And if you remember, what a negative 4 does is that it wants to move down. So again, in terms of your property for division powers, or power properties for division, that is your rule, which is that if you have 2 powers in a fraction with the same base, which I didn't put that in there, you just simply subtract the exponents. So again, if you've got 2 things that are of the same base, you simply take the exponents and do top minus bottom, and that will tell you how much is left over. And with all that, that brings us to our essential question. I've kind of taken that out of a few of those things because there really wasn't anything to ask as we were learning the rules. But the main thing you want to know is, how can you classify the exponential rules when everything is put together? And my advice is that with all these different options, you want to make sure you study your foundation of each rule. I told you that this would be an easy section, and it is, but you have to know everything you're supposed to know. So make sure you keep studying, because if this chapter is as important to you as some of it as it is with a lot of my students, you want to make sure you practice so that when you take the test, you don't make a silly mistake. So just going through this one more time. Again, x to the 2nd, x to the 4th, I believe this might even be on your notes like that. Actually, I don't think it is, but x to the 2nd, x to the 4th means if you get stuck on that and the first thing you want to do is multiply, just imagine saying, yep, that's 2 x's here, and that's 4 x's there, and all together that makes 6 x's, which is where you kind of want to imagine what's going on with that. You want to imagine here, when you see x to the 3rd going to the 2nd, that what you actually have is 3 x's twice, which means you have 3 x's expanded to 3 more x's, which makes x to the 6th. You want to remember the one that you just saw here, which is that you have 4x's on top, you have 2x's on the bottom, that anytime you have a fraction with the same thing on top and bottom, that you end up with just whatever is left over, which would be your x squared. And again, you did not divide those, you actually subtracted. That would be 4 minus 2. But either way, just make sure you study those foundational rules so that you can not make that bad decision when you take your test at the end of this chapter. Power properties also work with fractions. I think this is on your notes here, so make sure you do it. Again, what we're looking at here is x to the 4th, y to the 3rd to the 3rd. And again, this is a foundational part here, which is where we will look and say we have x to the 4th over y to the 3rd going to the 3rd power, which means we have x to the 4th over y to the 3rd 3 times. Again, this is the only time we have to do this, just so we understand what the rule does. And that ends up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's over 1, 2, 3, 4, 5, 6, 7, 8, 9 y's. But again, if you look at that, that is the same as if I distributed 3 times 4, which is 12. And if I also distributed it to the power which is below it, which is 3 times 3, or 9. And again, that's where those two numbers come from. So again, the power properties, anytime you have what I call a floating exponent out here, you just pretty much distribute it to everything no matter where it's at, and it works just as well. All right. In order to be most efficient and effective with power properties, make sure you practice and study these steps, practice and know these steps, because it is the most efficient, again, most direct way to make sure you get everything right. And what it does for you is it doesn't guarantee that anything's going to be easy, but it organizes your steps. And if you organize your steps, that means that you're less likely to do something out of order. You're less likely to do something crazy or silly along the ways. And what you want to do first, again, this is on the back of your sheet here, is you want to distribute any floating exponents. Again, floating's in quotes because it's really not an official term, but what you want to do is get rid of any exponent, and you want to do this again on your work, any exponent that is just floating outside of a parentheses. This 3 belongs to x. This -2 belongs to y. Those aren't floating, those are actual exponents. This 5 belongs to a whole set of parentheses. So the first thing you want to do whenever you have a complex problem is get rid of your floating exponents. So you want to rewrite that as 4 to the 5th, because remember you do, that's 1 times 5, x to the 15th, because remember we distribute it, and y to the -10th. And then from there, you would take whatever your next step was. All right, we're not going to work this out. I just want to make sure you understand what each step means. Distribute any floating exponent, again, just means distribute it to everything on the inside of the parentheses. Second thing you want to do after you've gotten rid of any floating exponents is move any what we call unhappy exponents. And again, circle this for your notes. That means any exponents, and this is not negative numbers with a negative in front, it's any exponents that are unhappy. And so what that means is you want to rewrite it with everything where it wants to be. So this a to the 5th actually wants to move up. The b to the 4th wants to stay there. This a to the 3rd actually wants to move down, and this b to the 5th actually wants to move up. Once you've got it set up to where everybody is what we call happy, then you would just follow your train on multiplication division properties. So what we just learned here is that because this is in a fraction, that we would subtract, and what we learn here is because both of these are right next to each other being multiplied, that we would add. And again, that is where your practice comes in. That's where you have to make sure you've put your work in with all the rules that you've learned. So let's get to a couple examples, and then let's go ahead and get you to your homework. So looking at a complex level problem here, let's just look and follow the rules we have. Remember, step number 1 is to get rid of any floating exponents. Because every exponent in this problem belongs to somebody, step number 1 is unnecessary, but we do want to move anything that's unhappy. So what we want to do is move our 3 squared down here. M to the 3rd, again, notice I'm just going piece by piece. N, remember that's n to the 1st, is happy where it's at. P to the -4th wants to go down. We'll worry about that in a second. The 2 squared also stays down here. M to the 2nd moves up, so I actually want to move that up here as close to M as I can. N to the 7th stays down here, And again, here's where the p's come in. So again, 3 squared is down, 2 squared stayed down, m to the third stayed, m to the second moved up, n stayed, n to the seventh stayed, p to the fourth moves down, and p to the second moves up. Again, make sure you follow that and that you know why all these numbers are where they are. Again, m to the third was happy, m to the second wanted to move up, n was happy, n to the seventh was happy, p to the negative fourth moved down, p to the negative second moved up, 3 to the negative second moved down, 2 squared stayed. Once you go there, now what you want to do is go ahead and follow your rules. Again, here we have m and m, which means that these two go together, making m to the fifth. Again, there's 2 m's and 3 m's, which make 5. In terms of your n's, you're looking at your numbers here. 3 squared you want to turn into a 9. 2 squared you want to turn into a 4. Again, in terms of your n's, what we would do is n to the, and again, here's your scratch work area. This is a 1, so it's actually 1 minus 7, which is n to the negative 6th. And again, the fact that that is a negative 6 means that your n to the 6th goes down here. And then the last thing you do is with the p's, top minus bottom, 2 minus 4, which is p to the negative second. And since it's negative second, that means that p wants to go down here. And the last thing you want to do is get rid of this multiplication here, so you end up with m to the fifth over 36 n6 p2. This is the most difficult type of problem you're going to see, but again, organizing yourself, having a scratch work area, understanding what the negative power means whenever you subtract. Again, 1 minus 7 when I did top minus bottom gave me a negative number, which means that it went to the bottom. Another way to visualize it is there are more n's on the bottom, which means my n should end up on the bottom. There are more p's on the bottom, which means that my p's should end up on the bottom. All of my m's were at the top, and there were 5 of them. And then again, just dealing with the numbers. But again, that's where your practice comes in. That's where you've got to make sure you're ready to do what you need to do. All right. Second example, rule number 1. Let's deal with this floating exponent. So distribute to every single thing in there. So that becomes x to the 12th, y to the 9th, z to the negative 6th, over x to the negative 9th, y to the 9th, z to the negative 3rd. Again, rule number 1 at least gets rid of the floating exponent, so you no longer have to think about distributive property anymore. Then you want to make sure everybody is happy. So again, x to the 12th is happy where it's at. X to the 9th wants to move up. Looking at your y's, you have a y to the 9th up here. You also have a y to the 9th down here. Looking at your z's, z to the 6th wants to move down, but z to the 3rd wants to move up. From there, we follow our work. Here we get x to the 12 minus 9, which is x to the 3rd. And again, a positive x means that x is on top, because it's a regular 3. Again, there are more. Actually, no, that's not it. I'm sorry. X to the 12 plus 9 is what I should be doing, which is x to the 21st. So that's actually what goes up top, is x to the 21st. Sorry about that. Y's, we do y to the 9 minus 9. Well, here's the thing. 9 minus 9 is 0. And remember that y to the 0, as we learned way back on the beginning of our work, is that anything to the 0 power disappears. So that means that our y's are no longer there. So pretty much what you can do when you have the same exact number of powers, you can kind of cancel those out. And then z to the 3rd, z to the 6th, that's what I meant to do here, which would be 3 minus 6, or z to the negative 3rd. And again, z to the negative 3rd means that z belongs down here, which means that that would be your final answer in that problem. All right. Now here's the hard part, and here's where it gets tricky. You will be working through 3 more sections of material. There are 7 sections in Chapter 7. And because of that, what's going to happen, none of them actually require your knowledge of power properties. And so you won't be using power properties on a regular basis for the next 3-4 days or until your test. So make sure you study this, because if you don't study the power properties, then when you take the test next week, at the end of next week, you'll be making small mistakes and you won't be at your best form. So be sure that you study the notes and practice from the first 4 sections of this for the whole rest of the time, all the way up to the test. Even if it just means doing a couple problems a day, just to revisit it. Make sure you take it seriously, because what happens on the test, since power properties represent a huge portion of it, is that you don't do your power properties. You take the test, you make 6 or 7 mistakes, which cost you a whole lot of points. Minimize those mistakes at least by studying as much as you can. So other than that, like I said, we move into something else tomorrow. And in terms of my class, you do have a test next Thursday, after we get some review days. So good luck.